video, let's try to find the best fit for the given data. Okay, so let's say you have the data as 1 comma 3, 2 comma 1 and 4 comma 4. So these points are in general of the form xi comma yi. So these are the 3 points. This is point 1, this is point 2, and this is data point 3. So we have 3 data points. Okay, and let's say first we want to fit a linear model. We want to fit a linear model, that is a line. Now the equation of the line will be yi is equal to axi plus b plus ei, where ei is the error. Ei is the error because our model may not fit the data exactly. Okay, so there will be some random error. So when we are actually predicting the data, okay, our predicted yi will be axi plus b. Okay, so now the error that I'm trying to find out. Okay, so firstly, when I do yi minus yi hat, this will be the error term. Now the error may be positive or negative, so I'll square it, and it is also easy to differentiate, as we'll see in the further steps. So squaring is good. Then I will find the sum of this error for all the 3 points. So I goes from 1 to 3 in this case because there are 3 points, and this is my sum of squared errors. Square and find the sum of squared errors. Everyone comfortable with this? Now let's substitute this equation. So this is nothing but I'll keep yi as it is, and instead of yi hat I will substitute axi. Okay, so yi hat is axi plus b. So I substituted over here, I took the square. Now I'll actually substitute the data that we have, the points that we have inside this, and I'll get this, which is, I'm just substituting the x and y values, nothing else. You can pause and verify yourselves if you want. Okay, I'm simply substituting the x and y values from the given data. Right now, basically, what is the concept of minima? Minima is a stationary point, right? So what do you mean by stationary point of a function? Okay, basically minima or maxima, extreme points are the stationary points of function, means the derivative at that point is 0. Derivative equal to 0, first derivative equal to 0. Okay, so normally the procedure is first derivative equal to 0, then you find the second derivative and you check the sign to find out whether it's a maxima or a minima. Okay, in this case we don't need to do that. We are only finding the first derivative and we are setting it equal to 0. Okay, and because there are two variables over here, so if you see, if you consider this as a function, if you consider sum of squared errors, can you say that sum of squared errors is a function of a and b? Because depending on what coefficients you choose over here, okay, the error will change accordingly. Depending on the coefficients a and b that we choose in the model, accordingly the sum of squared errors will change. Accordingly the position of the line will change, right? So if I have some data points, okay, and if I choose a line which is something like this, it will have a different error than choosing a line which has which looks something like this. So depending on what a and b values I choose, my error will change. So error is a function of a and b. Now this is a function of two variables, so therefore we'll have to use partial derivatives. So first partial derivative, dou SSE upon dou A, that is partial derivative with respect to A. I'm using the chain rule. Okay, so you can verify this. Okay, basically the term was 3 minus A minus B square. So square of something, so therefore 2 multiplied by something, then you go inside the bracket. Okay, so you go inside the bracket and the sign of A is minus, so therefore it is minus 2 3 minus A minus B. Similarly, when I try to calculate derivative of this with respect to A, so firstly it will be twice. Okay, first thing is, it is square of something, so twice that thing, and then you go inside the bracket and you find a derivative of 1 minus 2a minus b. So derivative coefficient of a is minus 2, so therefore this will have a derivative minus 4 1 minus 2a minus b. Similarly for the third term is 4 minus 4a minus b square. So square of something, therefore 2, this 2 will come out over here, right? And then minus 4 is the coefficient of a. When you're differentiating with respect to a, 4 is like a constant and b is also like a constant. So we are only interested in terms of a, which have a inside it. So minus 4 multiplied over here, so you will get minus 8 outside. So minus 8 times 4 minus 4a minus b, right? So this will be minus 8 times 4 minus 4a minus b, and you set this derivative equal to 0. Similarly, you find partial derivative of the error with respect to b. Now when b is considered as a variable, 3 and a are all constants. So again it will be minus 2 over here, right? Minus 2, 3 minus a minus b. For the second term, again 2 will come outside because square of something, chain rule, and now the coefficient of b is minus 1. So it will be minus 2, 1 minus 2a minus b. And for the third term, square of something, so twice, 4 minus 4a minus b. So 4, 4a are all constants when you are differentiating with respect to b. So only thing that matters are the b terms. So the coefficient is minus 1. So basically it will be minus 2, 4 minus 4a minus b. You can pause and try to calculate derivatives on your own. I'm assuming that everyone remembers the basic level of high school calculus. If not, you can post it in the comments and I can make a video on the same as well. But right now, this is the thing. Now we can do simple basic arithmetic and you will get basically two simultaneous equations. From the first partial derivative, you will get the equation 21a plus 7b equal to 21. And from the second partial derivative, you will get 7a plus 3b equal to 8. I strongly encourage you to do these steps yourselves. Then you will solve it simultaneously. How do you do that? For example, you multiply, if I call this equation 1, equation 2, multiply equation 2 by 3 and then subtract, right? Or right, so then, and you can simplify the things and all. I'm not showing the steps because that is not my aim. My aim is to show you the logic behind finding the coefficients of the best fitting line. So therefore we have found our best fitting line is half x plus 3 by 2. Normally you must have seen or used the formulae directly, but this is the logic behind the formulae. This is the calculus behind the formula. Okay. If you have any questions, any doubts, do post them in the comments below. Thanks for watching.